So let's try to understand the vector databases that we have for building the RAG systems, right? In RAG, as we learned in the previous lecture, we need a vector database to store our embeddings, right? So that is why we have different kinds of vector databases. We have Pinecone, Chroma database, which we have already seen in the project, right? And Viviet and Milvus and Facebook AI similarity search, right? This is also known as FIS. So we have different kinds of vector databases available, right? So let's learn one by one. Pinecone, this is a fully managed vector database designed specifically for machine learning applications, right? And here I have listed the key features best used for and the limitations. So the key features are, it is a serverless architecture with automatic scaling, and we have real-time vector search and updates, and it has support for hybrid search, high availability and data replication, and it also has pod-based architecture for performance optimization, right? So you know pod, it is a set of one or more containers that share a common network and storage space, right? So this is best used for performance optimization, and Pinecone is best used for large scale production deployments, right? And it is also best used for real-time recommendation systems, semantic search applications, enterprise level RAG implementations, right? And the limitations are, it is expensive, right? Higher cost compared to self-hosted solutions, and limited control over infrastructure and fixed pricing tiers, right? So keep these in mind when you are trying to pick the vector database, right? So that's about Pinecone. And the next one is Chroma database. This we have already seen in our project, right? Chroma database, it is an open source embedding database designed for RAG applications with focus on simplicity, right? What are the key features? Embedded database with no separate server required. So this is easy to use, and it is simple Python API, and we have support for multiple embedding models. We have already seen this. Persistent and in-memory storage options, right? So we have already seen this. We were able to store our embeddings in the vector database, and we stored them locally on our machine, right? And it is easy to integrate with LangChain. This part also we have already seen. And it is best used for prototyping and development, right? So let's say if you want to build any proof of concept quickly, then you can use this Chroma database to store our embeddings, and it is best used for small to medium sized applications and local development and testing, quick proof of concept projects, right? If you want to build something real quick, then you can use this Chroma database to store the embeddings. And what are the limitations here? Limited scalability for very large data sets. So like I said, this is only used for small to medium sized applications, and it is not applicable for production level applications, right? And it has fewer enterprise features, and there is no built-in clustering capabilities, right? You know clustering, right? So clustering is a machine learning technique that uncovers patterns hidden within the data, right? So if you use Chroma database, we don't have built-in clustering capabilities, right? And the next one is Viviet. So Viviet is an open source vector search engine with built-in vectorization capabilities, right? So what are the key features? It has GraphQL based query interface, right? And GraphQL is an open source data query and manipulation language, right? So we have GraphQL based query interface in Viviet, and we have built-in vectorization modules, multi-tenancy support. That means that a single instance of the software, and it will support infrastructure that can serve multiple customers, right? So that is multi-tenancy support. And CRUD, create, read, update and delete, right? So you can perform all these operations on vectors, and it has Docker first deployment, right? And Viviet is best used for complex search applications, right? And it is also best used for self-hosted production deployments, and it's best used for applications requiring custom schemas. And sometimes you may require to build custom schemas, right, when you are building an application. So in that case, you can pick Viviet. And if your project needs GraphQL integration, then you can pick Viviet. And what are the limitations here? Steeper learning curve, because first you have to get familiar with this GraphQL based query interface, right? So there is a learning curve involved, and it is more complex setup compared to simpler solutions, and it requires more infrastructure management, right? This is used only for the complex search applications, right? And the next one is Milvus. Milvus is an open source vector database built for scalable similarity search, right? And what are the key features? It has horizontal scalability, means it is a process of adding more instances of the same type to the existing pool of resources, right? So that is the use of Milvus. And it has got multiple index type support, cloud native architecture, advanced filtering capabilities, and it has support for multiple vector similarity metrics, right? And Milvus is best used for large scale deployments, and it is best used for complex similarity search applications, enterprise search solutions, and it is best used in computer vision applications, right? And what are the limitations here? It is complex deployment and maintenance when compared to other vector databases, and it requires significant resources as well. And the other limitation is steeper learning curve for optimization, right? And the next one is FAIS, right? So Facebook AI Similarity Search. This is a library for efficient similarity search and clustering of dense vectors. And what are the key features? Highly optimized for performance, multiple index types for different use cases, and it has GPU acceleration support, compact data storage, and it also has advanced clustering capabilities, right? And this is best used for research projects and high performance requirements and custom implementation needs, applications requiring fine-tuned control, right? And what are the limitations? There is no built-in persistence, right? So requires custom implementation for many features, and it has got limited metadata management. So that's about Facebook AI Similarity Search, FAIS. And now let's try to compare these vector databases with the features. When it comes to ease of use, like we saw this Chroma database, this is very easy to use and it is also free, right? And after Chroma database, we have Pinecone is easy to use, and Viviet and Milvus, they are in a medium, and FAIS is low, right? So if you want to build something real quick, like a proof of concept, then you go for Chroma. And when it comes to scalability, Milvus is ranked very high. Next one is Pinecone and Viviet. These two are high, and FAIS is medium, and Chroma database is low. If your application requires scalability feature, then don't go for Chroma, right? So you can best use Milvus. And managed service, Pinecone S, Chroma database no, Viviet optional, Milvus optional, and FAIS is no. And cost, both Chroma and FAIS are free, and Pinecone is high, and Viviet and Milvus are mixed, right? And when you are building production ready applications, then you go for Pinecone or Viviet or Milvus. And Chroma database, you have only limited support, and FAIS requires some work, right? So there is a lot of learning curve, and it requires more work when you use FAIS, right? So when you're trying to select a vector database, try to consider these factors. Scale, that means how many vectors will you store and search, right? And the next one is performance, that is what are your latency requirements. Budget, what's your infrastructure and maintenance budget. Expertise, what is your team's technical capability. And features, right? Do you need specific features like filtering or clustering, right? So you keep all these different factors in mind when you're trying to select a vector database, right? And what are some of the common use cases? So if you are building in generative AI application that requires semantic search, then you go for Pinecone or Viviet. For RAG applications, Chroma database or Pinecone database, right? So we have already seen how to use Chroma database when building RAG application, right? And for research projects, Chroma database or FAIS, right? And for enterprise solutions, Milvus or Pinecone. For prototyping, that is proof of concept projects, you can go for Chroma database or FAIS, right? And we have already seen how to implement RAG applications by using Chroma database, and we have already went through all the key features of different other vector databases as well. And depending on your requirement, you can deep dive into other vector databases, right? Thank you. Now let's learn the different text chunking methods that we use when building RAG systems, right? But before we start learning these different chunking methods that are supported by LangChain, let me quickly summarize what we learned in the previous lecture on RAG and why do we need these chunking methods, right? So let's say if you ask an LLM what is the weather today, right? So LLM has a cutoff date on when it was last trained, right? So we are asking a question which is related to today, right? So it goes to internet, that is tools, and searches and retrieves the answer for us, right? And question number 2 is, let's say if you ask any question related to your company specific HR information, right? That is specific to your domain. Then it goes to vector database, processes, and retrieves the answer for us, right? So this is the process of RAG, right? RAG is nothing but a search on your domain specific data, right? And then let's say question number 3 is what is LangChain, right? So this is a general question. For general intelligence, LLM will not use RAG, right? Because it already understands and retrieves the answer for us, right? So depending on your input, you have to choose which one to use, right? And we also learned context window, right? So first of all, why do we need to chunk our input data? Whenever we try to build any generative AI applications, we need to keep the LLM context window in mind, right? We already learned that each LLM has its own context window size. So context window is nothing but your input plus the response, that is output, together total number of tokens. Input tokens plus output tokens all together is nothing but your context window. And we cannot pass the whole input document, right? If the document size is really big, for example, let's assume your input document size is in gigabytes or petabytes, right? And if you try to pass these huge documents which are beyond LLM's context window size, then the LLM cannot process that data, right? So to avoid this LLM context window limitation, what we are trying to do, the easiest option is to divide the input document into chunks, right? So that is the reason we are trying to chunk our input document to avoid the context window limitation, right? Now let's try to learn different chunking methods that we use when we are trying to build a RAG application, right? So let's learn what kinds of chunking methods LangChain supports, right? So text chunking is a crucial pre-processing step in RAG, Retrieval-Augmented Generation systems, where documents are broken down into smaller manageable pieces, right? So we've already seen this creating chunks in our question answer RAG application, right? And we have different chunking methods: character based chunking, word based chunking, sentence based chunking, paragraph based chunking, overlapping chunking, and semantic chunking. And we have already seen recursive character text splitter, right, which we have used in our RAG question answering project. So let me quickly show that so you will relate to that. So if you see here, we used recursive character text splitter, which is inside LangChain text splitter, and we have used this and created our chunks, right? So we got the text splitter and then we used a split text method to get the chunks. So similar to recursive character text splitter, we have different other chunking methods. So let's learn one by one, right? So what is character based chunking? It splits text into chunks based on a fixed number of characters. That is, divide your whole input data based on characters. For example, 100 characters per chunk. That is, whenever 100 characters completes, then it will chunk there. So if you see here, we have this input text and we have a total of 448 characters. And whenever it completes 100 characters, it will chunk there, right? And it is simple and straightforward approach. It doesn't consider semantic meanings or natural breaks. And what are the advantages? It is easy to implement, right? So wherever it completes 100 characters, just chunk there. And consistent chunk sizes, because all the chunk sizes are just 100 characters. Works with any text format, right? And what are the disadvantages with this character based chunking? may break words and sentences in unnatural places. For example, if you see here, the 100 characters is at off, right? So after off, it is trying to chunk. So machine learning a subset of, right? So it chunked there. So with that, what will happen? It doesn't preserve context or meaning. So it will be hard to preserve the context, and it can create chunks that are hard to understand in isolation. So this is one chunk, and then from AI, again next 100 characters, right? So that is one chunk, right? So because of this character based chunking, it is really hard to preserve the context or meaning, right? And then the next one is word based chunking. So what it is, it divides text into chunks containing a specific number of words. For example, let's take this input text, right? So we have a total of 68 words. And let's say if you're trying to divide 50 words per chunk. So from artificial intelligence until AI. So this highlighted portion is 50 words, right? So we are trying to chunk by number of words. So it preserves word boundaries more natural than character based chunking. In character based chunking, so let's say if it completes 100 characters at O, right? So we will lose the context, right? So at least with word based chunking, it preserves word boundaries and it is more natural than character based chunking. This word based chunking is better than character based chunking. And what are the advantages? It prevents word splitting, right? With the character based chunking, we may end up splitting the words, but at least this will prevent word splitting, and it is more predictable chunk sizes in terms of content, right? And it is better readability than character chunks. And what is the disadvantage of using word based chunking? May still break sentences midway, right? So here if you notice, we have a total of 68 words and we are trying to divide 50 words per chunk. So it chunked midway of this sentence, right? And it doesn't consider natural paragraph breaks, right? So it is not trying to consider all the way till language period, right? So this is the paragraph break, right? So it is not trying to consider till here. It is trying to chunk wherever it completes 50 words, right? And chunk sizes can vary significantly in terms of characters, right? But at least this word based chunking, this is better than character based chunking. Okay. And the next one is sentence based chunking. So what is sentence based chunking? Groups a specific number of sentences together. For example, if you see, this is our input text, right? If you notice here, we have 5 sentences here. And let's say if you're trying to divide 2 sentences per chunk, right? So with sentence based chunking, it uses natural language processing NLP to identify sentence boundaries, and it preserves complete thoughts and ideas, right? So we are not chunking in between the sentence. So at least we will be able to preserve the context. And what is the advantage of using sentence based chunking? It maintains sentence integrity. It preserves natural language flow, so it will be easy to understand, right? And better context preservation, more meaningful for NLP tasks, right? So if you are trying to build a generative application and trying to solve an NLP task, right, then in that case better you use sentence based chunking. But what is the disadvantage of sentence based chunking? Chunk sizes can be very uneven, right? So some sentences can be very long and some sentences can be very short, right? So chunk sizes can be very uneven, and long sentences might create oversized chunks, right? And also it requires reliable sentence boundary detection, right? But at least this sentence based chunking, this is better than both character based chunking and also word based chunking. But this sentence based chunking, this is best used when every sentence in your input document has meaning, right? For example, emails or your client invoices or WhatsApp chat messages, right? We can use these sentence based chunking. So depending on your input, we need to pick the right chunking method. And this sentence based chunking method is best used for small size input documents, right? And the next one is paragraph based chunking. So what is paragraph based chunking? This uses paragraph breaks as natural chunk boundaries, right? For example, let's say this is our input text. If you notice here, we have 3 paragraphs and we are trying to divide every 2 paragraphs into one chunk, right? So it preserves document structure and maintains complete topics or ideas. So each paragraph will have its own meaning, right? So at least we can try to preserve the context, right? What is the advantage of using this paragraph based chunking? It preserves natural document organization and it keeps related content together, maintains author's intended structure, ideal for well formatted documents. For example, let's say if you are using your 10K financial input company report, right? So this is usually, the 10K report is usually in a standard fixed format, right? So each paragraph will have its own meaning and it doesn't need to rely on other paragraphs, right? So first you can try to chunk based on paragraphs and then chunk again based on subtitles or rechunk further, right? So you can use this paragraph based chunking when the input document format is very standard, right? And what are the disadvantages of using paragraph based chunking? It can give highly variable chunk sizes, right? For example, let's say you have an upload button and if user is trying to upload different size of documents, right? Then one paragraph can contain only 1 or 2 lines, or maybe other paragraph can contain hundreds of lines, right? So if the user is uploading different size of documents, then this may not be a good idea, right? So use this paragraph based chunking only if you know the input format of your system, right? And the other disadvantage is it depends on consistent paragraph formatting. And if you know your input document paragraph formatting and if it is consistent, then only you go for paragraph based chunking. And it may not work well with poorly structured text, right? So it has to be in well formatted structure, then only you go for paragraph based chunking, right? And the next chunking method is overlapping chunks. So overlapping chunks creates chunks that share some content with adjacent chunks. For example, let's consider this is our input document text. Let's say if you are trying to chunk till data, right? And then again you are trying to overlap from enables till data in the next chunk, right? So that is overlapping chunking, right? It uses a sliding window approach, right? So this will help maintain context across chunk boundaries. So from artificial intelligence till data we are chunking, and then again from enables till next chunk. So we are trying to overlap the chunks, right? So what is the advantage of overlapping chunks? We will get better context preservation and reduces information loss at chunk boundaries, right? Because we are trying to overlap, and it improves retrieval accuracy, helps with context dependent queries. And what is the disadvantage? Because we are trying to overlap, so that means more tokens, right? So it increases storage requirements and it creates redundant data, right? So first chunk will have this data and second chunk also will have this overlap data, right? So which can create redundant data, and it may require deduplication in search results. So in your search results we may see duplicate results, right? And it is more complex to implement than other chunking methods. And we have already used this overlapping chunking, right? And we generally apply overlapping chunks along with either paragraph or word or sentence chunking, right? And how many overlaps we use? This again is a user defined parameter. So this may or may not work all the time. For example, let's see our code. So if you notice here, we have used overlapping size of 50, right? So this is a user defined parameter. And depending on your input document, you have to pick this parameter by trial and error, right? So this may or may not work for varying input documents, right? So that is one of the disadvantages of using overlapping chunks. And the next one is semantic chunking. So semantic chunking splits text based on semantic patterns or rules, right? So if you notice in our code, we are using this pattern. Whenever you see 2 new lines or 1 new line or period or space, try to chunk here, right? So that is what we are telling. Or semantic chunking uses natural topic boundaries and it considers document structure and content meaning. So with semantic chunking, it maintains logical content grouping, preserves topical coherence, better for knowledge retrieval, more natural for human comprehension. And what are the disadvantages? Complex to implement correctly, and it requires sophisticated pattern recognition, and maybe domain specific, can be computationally intensive. This is one of the most famous chunking method. That is 80 to 90% of the cases we use this semantic chunking because we can try to preserve the context, right? And based on semantic meaning, we are trying to chunk here, right? Whereas in other cases, we are trying to give the chunk size or chunk overlap. We are actually relying on some parameters. But whereas in semantic chunking, we are just relying on a pattern. For example, let's say you have a Markdown file, right? Or HTML file as input. In that case, you go for semantic chunking, right? For example, let's say when we are trying to create a Markdown file, right? This is the Jupyter notebook. And if you give hash heading 1 and click run, so you can see how did we create this with hash, right? So there is a pattern here. And if I give 2 hash and then give heading 2 and run it, so select the Markdown and run. So this is heading 1, this is heading 2, and for heading 3, give 3 hashes, right? And then select the Markdown and run. So you can see this is heading 3, right? So we are able to create different headings by using this hash, right? So this is a pattern, right? So in Markdown, whenever there is a hash, right, it means a heading, right? So you can just tell in the code, whenever there is a hash, try to chunk. So with this semantic chunking, that is, there is a pattern here. So this is one heading. Under the heading, there will be some content, and second heading, there will be some content, third heading, there will be some content. At least with this pattern, we can preserve the context better, right? So majority of the times we try to use this semantic chunking, and LLM is smart enough to look for these markdowns, right? And it will try to understand the format easily. So before we try to use the input document, we have different packages available that can convert our input text and office documents into markdown, right? So for example, Duckling. So if you see this Duckling website, this is the Git repo. And if you see here, we have the code here, right? To convert individual documents with Python, use convert for example. So you provide the PDF document and it will try to convert into Markdown, right? So either you can use Duckling or you can also use Markdown, right? So Markdown is a Python tool for converting files and Office documents into Markdown, right? So once you convert your input document into Markdown, LLM will be able to understand this format very easily, right? So that is why you always try to convert your input document into Markdown and then you apply semantic chunking, right? And LangChain also supports Duckling, right? So let me show you that. So this is our official LangChain Duckling documentation, and we have Duckling support from LangChain as well, and it is clearly documented here. You can try to explore more by checking these examples, right? But the objective of Duckling is it tries to parse PDF, docx, PowerPoint or HTML and other formats into a rich unified representation including document layout, tables, etc., making them ready for generative AI workflows like RAG, right? So what we are trying to do, before we use our chunking methods, try to apply Duckling, right? And then it will create a patterns and then you apply semantic chunking. So that's about semantic chunking, right? So we talked about character-based chunking, word-based chunking, sentence-based chunking, paragraph-based chunking, overlapping chunking, and semantic chunking. All right, thank you. So let's talk about some of the best practices when you're trying to choose a chunking method, right? So we learned we have different chunking methods like character-based chunking, word-based chunking, sentence-based chunking, paragraph-based chunking, overlapping chunking, or semantic chunking, right? So we have different chunking methods. So let's see the best practices, right? So first thing is consider your use case. For example, let's say if you're trying to build an application with simple text storage. So in that case, go for character based chunking, right? So character based, or you can also use word based chunking. For example, let's say if you're building question answer system, right? In that case, go for sentence-based chunking, right? Sentence, or you can also use paragraph-based chunking. This will work best. Either sentence-based or paragraph-based chunking method is best when building question answer system RAG applications, right? And if you're trying to build an application that has technical documents, right? So in that case, go for semantic chunking, right? So depending on your use case, you have to pick a right chunking method. And the second best practice is think about your content, right? For example, if your input document has well-structured documents, then you go for paragraph-based chunking. And if your input document has technical documentation, then you may want to use semantic chunking, right? And the input document has news articles, right? So in that case, sentence-based chunking will give best results, right? And the third best practice is consider your model, right? Because some LLMs have specific token limits, right? So we already know each LLM has the context window size, and context window size should influence chunk size also, right? And also try to consider model's ability to handle context, right? So you have to pick the right model also, right? So depending on your model, you have to pick the right chunking method. And balance trade-offs, right? For example, chunk size versus context preservation, right? So if you want to preserve the context, obviously you need more chunks, right? So you have to balance between chunk size versus context preservation, or processing speed versus chunking quality, right? So obviously if you have more chunks, then it will take more processing time, right? So you have to balance between processing speed versus chunking quality, or storage requirements versus retrieval accuracy, right? So more chunks, it will take more storage. So you have to balance between storage requirements and retrieval accuracy, right? So keep these different best practices in mind when you are trying to pick a chunking method. All right. Thank you. So we understood different text chunking methods that we use when building RAG systems, right? So we have character-based chunking, word-based chunking, sentence-based chunking, paragraph-based chunking, overlapping chunking, and semantic chunking, right? And like I said before, text chunking is an important pre-processing step when building any RAG system, right? That is Retrieval-Augmented Generation systems, right? And always remember that the best chunking method often depends on your specific use case, content type, and the requirements of your RAG system, right? And sometimes you might even need to combine multiple chunking methods, or you may want to create your own custom chunking method approach for optimal results, right? Now let's see the demo. Let me go to our code editor, VS Code. So I think I didn't show you how to create a workspace before when we are building RAG application, right? But you can click on Save Workspace As, and you can name anything. Here I named Build Generative AI Applications, right? So everything will be in one place, right? And then you can create separate folders here. Once you create the workspace, here I opened RAG demo and I saved it here, right? So this is how we created our question answer RAG application, right? So now let's see different chunking methods. So if you see here, I created an empty folder, chunking methods demo. Now let's try to add the empty folder that we created to the build generative AI applications workspace. Come here to the Explorer and right click and add folder to workspace, and select this folder and add, right? So now we are inside chunking methods demo, and here try to create a new file, and it is Python file, right? And let's save it as character text splitter demo and save it, right? So inside RAG demo folder, we built the RAG application before, right? So let's close this, and then inside chunking methods demo, I created a new Python file and I named it character text splitter demo, right? Now let's see how we can use character text splitter, right? So before we do anything, first we have to install all the required packages. So here, like I said, we are using LangChain packages. So make sure you install LangChain, right? You have to go to the terminal, click on view and terminal, right? So here you can enter pip install LangChain and hit enter. And then The next one is pip install LangChain text splitter, right? And then hit enter. And then pip install tick token, hit enter. Either you can give this way or you can give all in one line also. Just give spaces, space, LangChain text splitter, and all the three packages in one line, right? So this is how you will install all the required packages, right? So once you install all these required packages, now let's try to import the required packages. Since we are trying to use character text splitter, I imported character text splitter from LangChain text splitters, right? So once you import that, the first thing is we have to prepare our input document, right? So I'm taking this sample text as our input document, right? So this is our input document text, right? So this is our sample text. Here you can replace with any text you want. This is your domain specific data, right? So let me save this. And once we have the input text ready, then let's see how to implement character text splitting, right? So let me just add a print statement, character text splitter example, and we know character text splitting is best used for simple text splitting, right? Now we have to make use of this character text splitter which is inside LangChain text splitters, right? So let's use that. So inside character text splitter we have these three parameters: separator, chunk size, chunk overlap, right? And we are trying to separate by two new lines. So wherever we have two new lines inside our input document, then chunk there, and the chunk size should be 200 and chunk overlap is 50, right? We already know these two parameters, right? It will try to divide by 200 characters with an overlap of 50, or within 200 characters in case if there is this pattern, two new lines, then it will chunk there, right? Now inside this splitter we know we have split underscore text method, right? So let's use inside the splitter we have split underscore text and pass our sample text, that is our input document, right? Once we pass it, then we will get the chunks. Now let's try to print the chunks that we have inside the chunks, right? So let me save it and click on run. So now you can see we have our chunks. Let me go to our input text, and if you see, this is our first chunk, right? Because we see two new lines here. This is our first chunk, and from here till here, right? This is our second chunk, and from here this is the third chunk, right? And so on, right? So now we got the chunks. Now if you want to see the data type of these chunks, you can use type method, and let's run it. So now you can see this chunks is of type list, right? So inside the list we have all the chunks available. Now let's try to loop in so we can read the individual chunks, right? So what we are using, for loop, for each chunk inside this chunks list, I'm trying to loop in and then get each chunk, right? So now let me rerun the code. So now you can see we have a total of 6 chunks, right? So the first chunk is introduction to machine learning. So if you see here we have new lines, right? So that is why it chunked there. And then the next chunk is still here, because after this we have a new line. And then the next chunk is till here. And then the fourth chunk is till here. And then the fifth chunk is this. And then the last chunk is still here, right? So that is how we can implement character text splitter and divide our input document by number of characters, right? So let me quickly explain what we did here. First thing is we installed all the required packages here. In fact, you actually don't need this tick token now. That is used in another chunking method. I will explain later. So make sure you install these two required packages and then try to import character text splitter, because that is what we are using to split our input document by character chunks, right? and then we prepared our input document here. So this is our input document. Here you can replace with any content you want. This is specific to your domain, right? And then here I'm just trying to print, and then we are using character text splitter, and the separator is 2 new lines, right? So whenever there are 2 new lines, it will try to chunk there, and the chunk size is 200 and chunk overlap is 50. We are trying to overlap 50 characters from previous chunk, right? So that is what this chunk overlap is. And inside this splitter we have split underscore text. We have to pass our input text here, so we will get the chunks, and this chunks is of type list, right? Now we are trying to loop in each chunk inside this list and trying to print it here. And this is how it divided the whole input document into 6 chunks, right? So I hope you understood this character text splitting, right? And this character text splitter is best used for simple text splitting, right? Thank you. So we have seen character text splitter, right? So what it did, every 200 characters it tried to chunk, right? And all these parameters are user defined parameters, right? So you can experiment here. If the separator is present, that is 2 new lines is present within the chunk size of 200 characters, it will try to chunk there. This is what we learned in the character text splitter. Now let's see the next chunking method, that is recursive character text splitter, right? So inside this chunking methods demo, let me try to create another Python file and let's save it, recursive character text splitter demo. And now, like I said, in case if you did not install any of these packages, make sure you install LangChain and LangChain text splitter, right? And once you install, the next thing is we have to import them, import the packages. Here we are not using character text splitter, this is recursive character text splitter, right? So make sure you import recursive character text splitter from LangChain text splitters, right? So once you import the module from this package, the next step is, let's see how to implement this recursive character text splitting, right? So let's take the same input. So I'm copying from character text splitter demo, right? So I'm taking the same input document and let me just try to print recursive character text splitter example, and this is better for preserving context. So now let's use of this recursive character text splitter and split our input document, right? So inside recursive character text splitter we have 4 parameters here. The first one is separators. Here we are giving separators as 2 new lines or 1 new line or period or space, and the chunk size is 150, chunk overlap is 30, and the length function is we are telling it to use len, right? So what we are telling to the recursive character text splitter, whenever there are 2 new lines or 1 new line or period or space, then you try to chunk there, and each chunk size is 150 characters and chunk overlap is 30, right? It will try to overlap 30 characters from previous chunk so that we can preserve the context. So that is the advantage of using this chunk overlap. And if you notice, what is the difference that you can identify between this character text splitter and recursive character text splitter, right? If you see here, inside character text splitter you can only define one separator, right? Here we only define 2 new lines, whereas in recursive character text splitter we can define multiple separators. If you see, we defined 2 new lines, 1 new line, period and space, right? So inside character text splitter we are able to define multiple separators. So that is one of the difference between character text splitter and recursive character text splitter, right? So what we are telling here, if the separators appear within the chunk size of 150, then it will forcefully do the chunk by the separator even though we defined the chunk size as 150, right? We already know that. And once we get the splitter, the next thing is we have to call split text method, so we will get the chunks, and we know this chunks is of type list, right? So we got list of chunks, and now let's try to loop in so we can print each chunk inside the chunks list. So what we are doing here, we are trying to loop in this chunks list and we are trying to print chunk 1, what is the value, chunk 2, what is the value, right? And save it. Now let me run this file. So if you see, this is where we ran, right? Recursive character text splitter example, this is better for preserving context. So if you notice, how did we divide let me take you to the input document. So this is our input document, and if you see, we gave our separators as 2 new lines or 1 new line or space or period, right? So that is how it will try to chunk, right? So it chunked one here and the other one here because there is a period, right? And then from here till the end of this sentence, and then the fourth chunk is still here, and fifth chunk is still here, and then the sixth chunk is till here, and then the next chunk, seventh, right, till neural networks, and so on. So it created a total of 12 chunks by using these separators, right? So that is how you can use recursive character text splitter, and by using recursive character text splitter you can define multiple separators. So that is the advantage of using recursive character text splitter. And if you notice, we already used this recursive character text splitter inside our RAG application, right? So let me quickly open this RAG demo file, and here you can see recursive character text splitter, and we are using the same separators, right? And this is our input document before, right? So what we did here, first we installed all the required packages. This is not required to install every time. So once you install here, you don't have to install again here, right? But make sure you install these required packages in case if you don't already. We have to import recursive character text splitter module from LangChain text splitters package, and this is our input document, and here we are trying to just print this line. And what we are doing here, we are using recursive character text splitter, and we have these 4 parameters. The first one is to define the separators. Here we can define multiple separators, and the chunk size is 150, so we are telling it to divide by 150 characters, and chunk overlap is 30, so it will try to overlap 30 characters from the previous chunk. And the length function is len. So even though we define chunk size as 150, it will forcefully try to chunk whenever there is a separator with this pattern, right? So that's how you can use character text splitter, and this character text splitter is best for preserving context, right? Thank you. So far we have seen character text splitter demo and also recursive character text splitter demo, right? And the next one is, let me try to create a new Python file here. So we can see the third chunking method, which is nothing but Markdown header text splitter demo. So this is our third chunking method, and like before, in case if you haven't already installed the packages, make sure you install LangChain and LangChain text splitter packages, and then we have to import our required modules here. So we don't need recursive character text splitter here because we are trying to do Markdown header text splitter, right? So let's try to import Markdown header text splitter from LangChain text splitters, right? And then again, I'm taking the same input document. This is our sample text that we are trying to chunk, right? And what we are trying to do with Markdown header text splitter, this is ideal for Markdown documentation, right? And I've already shown you Markdown, right, in Jupyter Notebook. So if you notice here, this is the 1 hash is for heading 1, and 2 hashes for heading 2, 3 hashes for heading 3, right? So we have this Markdown feature available inside Jupyter Notebook. This Markdown header text splitter is best for Markdown documentation, right? So what you can do before you even try to chunk by using Markdown header text splitter, first thing is you try to convert your input document by using duckling or Markdown, and then try to convert this input document into Markdown, and then you try to apply Markdown header text splitter, right? So that way you will get more accurate results, right? I've already explained in the previous lecture, but let me quickly show you what is duckling. So if you see here, so this is our Git repo, right? So you can pass your PDF document and you can try to convert into Markdown. And we also have mark it down. So this is the mark it down Git repo, right? So mark it down is a Python tool for converting files and Office documents to Markdown, right? So it will convert our input document into Markdown so that LLM will be able to understand these Markdowns easily, right? And we already saw this one too, LangChain duckling, right? So LangChain duckling parses PDF, docx, pptx, HTML and other formats into a rich unified representation including document layout, tables, etc., making them ready for generative AI workflows like RAG, right? So we have duckling support from LangChain too. So it's clearly documented here. In case if you want to deep dive, you can go through this documentation. We have different examples here, right? So before we use this Markdown header text splitter and try to chunk our input document, before you do that, first thing is try to apply duckling on this input document. So that way LLM will be able to easily understand. But here I've already added this markdowns, that is 1 hash, 2 hash, 3 hashes, etc. But in case if your document doesn't have anything, you try to first pass this one to the duckling and then get this markdown ready. Now let's see how to use Markdown text splitter, right? So here we are telling it to divide whenever these are kind of separators, right? So we are telling it whenever there are 1 hash or 2 hash or 3 hash, right? Then split there. So if you notice here, these separators are more reliable, right, than defining the chunk size. So if you notice here, we are telling chunk by every 150 characters, right? So these are user defined parameters. Whereas here, we are not defining any parameters here. Instead, we are telling chunk whenever you see these markdowns, right? So this is more reliable than either character text splitter or recursive character text splitter, right? And if you want to deep dive into this Markdown, I've already explained Markdown features in detail by using Jupyter Notebook, right? So please go through that lecture if you haven't already. So first we defined our pattern here, that is split by markdowns, right? And then now let's try to use this Markdown text splitter and try to create chunks, right? So we are using Markdown text splitter, and inside this we have a parameter called headers to split on, and we are passing this one. So we are telling it to chunk by these values, right? So whenever there is 1 hash or 2 hash or 3 hashes, these are markdowns, right? Inside this we know we have split underscore text method, right? So that we will get the chunks. And let me try to print and see what we have inside this docs, right? So let's run it, and now you can see this is the overall, but let me try to print each individual chunk, so that way it will be easy for you to understand. So let's loop in, and what we are doing here, we can get metadata of the header and the chunk belongs to which page, right? So we have methods from LangChain. So that is why we are using LangChain, right? Now let me save it and run. So now you can see document 1, and the header is, there is no header. Content, what is the content here? This is the content. So if you see here, it tried to print till end of this, right? So whenever there is 1 hash, so that is the markdown, right? So it chunk till end of this one, and the second chunk is this part, right? And here there is no content, right? So that's why that it didn't print anything here. And the third one is, here we have this markdown, right? So it tried to chunk here. And the fourth one again is, here we have 2 hashes, right? So that's why it tried to chunk over here, right? So now you understood. So what we did here, first thing is we try to install the required packages and try to import the required module, that is Markdown header text splitter from LangChain text splitters package, right? And then we prepared our input document here, and it already contained markdowns, right? But in case if your input document doesn't contain markdown, you can make use of duckling and then try to create these markdowns, right? And once you get the markdowns, then you can use Markdown header text splitter, right? And this is the pattern we are telling. So whenever you see these markdowns, then try to chunk there, right? So this is best used for Markdown documentation, right? Thank you. So far we have seen character text splitter, recursive character text splitter, and then we also saw Markdown header text splitter, right? So when compared to recursive character text splitter and character text splitter, this Markdown header text splitter is more reliable, right? Because we don't have to worry about defining this chunk size or chunk overlap, right? Those are user defined parameters, right? We are just chunking by these markdowns. So this is simple and easy to use, because this 1 hash means heading 1, 2 hashes means heading 2, 3 hashes means heading 3, right? So these are markdowns. Chunking by markdowns is more reliable than defining your user defined parameters, because these chunks are highly dependent on your input document, right? In case if you change your input document, you will have to adjust these chunk size and chunk overlap parameters also, right? So this Markdown header text splitter is more reliable than other two chunking methods, right? Because by using this Markdown header text splitter, we will be able to retain the context much better than other chunking methods. And we have these tools, this PyMo PDF, aim to make it easier to extract PDF content in the format you need for LLM and RAG environments, right? It supports Markdown extraction as well as Llama index document output, right? So we have built-in functions available here. So you can make use of this. And then first thing is you try to convert your input document into Markdowns. And then you apply Markdown header text splitter, right? And we also have one from Llama Parse, right? So this is the Llama index. Llama Parse is the world's first generative AI native document parsing platform built with LLMs and for LLM use cases, right? And what is the objective here? The objective of Llama Parse is to parse and clean your data, ensuring that it's good quality before passing to any downstream LLM use case such as advanced RAG, right? So you have different techniques available to convert your input document into Markdowns, and then once you convert it, then you can apply Markdown text splitter, right? So that way you can create the chunks and it is best for Markdown documentation, right? And now let me show you one other chunking method. So file, new Python file, and let's save it, token text splitter demo. So again, in case if you haven't installed already, make sure you install now, and let me copy the same input here and save it. So here instead of Markdown header text splitter, we are using token text splitter, right? And make sure you also need to install tick token. So install that package as well. And let me add the print statement here. And now let's try to use this token text splitter and try to create the chunks. So here we are passing chunk size as 100 and overlap as 20. And then we got the splitter. Now let's get the chunks by calling split underscore text method inside splitter, right? So that way we'll get the chunks. We are passing this sample text and we want to chunk by 100 characters and overlap is 20. And now we got the list of chunks. Now let's try to loop in each chunk, and chunk 1 is what is the value, chunk 2 what is the value, right? Now let me save it and run the code. Couldn't import tick token Python package. So we got an error here. Module not found error, no module name tick token, right? Line number 43. Okay, so it is not able to find this module. So let me try to install this package and then rerun the code, right? So whenever you see module not found, just try to install the relevant package, right? So what we are doing here, we are telling it to divide by 100 characters, right? So if you see here, we got a total of 3 chunks, right? So with the token text splitter, it chunks based on tokens, right? So with the chunk size and chunk overlap, these two are again user defined parameters, right? And it is complex to set these parameters. That will work for all the scenarios, right? Because we are just hard coding this input document here. But in case if you change your input document, accordingly you have to change these chunking parameters also, right? So again, this is complex. And for example, let's say you built a question answering chatbot RAG system and assume there is an upload button to upload the input document, right? And in case if user uploads different formatting documents, for example, PDF or one from PPT or document or Excel or text file, right? Different formatting documents with varying size, right? So each document with different size, meaning PDF has 100 pages or Word has 1000 pages, etc. Because the data is really complex, right? In real time, here we are hard coding just few lines, so we'll understand the concept. But in real time, the data is really complex, right? So you have to change your chunking parameters also according to your input document, right? So in that case, this chunk size and chunk overlap parameters are hard to control because we don't know what the user can upload, what kind of size the user is going to upload, right? The user can upload 100 pages or 1000 pages, right? We cannot really define these parameters for every single input, right? So it's better not to use this token chunking in that case. But when is this best used for? This is perfect for LLM token limit management, right? We know each LLM has context window limitation, right? So that is when this token text splitter is best used, right? So with this we learned character text splitter, recursive character text splitter, markdown header text splitter, and token text splitter also, right? So now you understood different chunking methods, and the chunking is very important. Whatever you chunk, accordingly you will retrieve the answer as the output, right? Because what we did in RAG application, we chunked our input document and we created embeddings and we stored inside our vector database, right? And whatever we stored, those will be retrieved, right? So that is why this chunking is very important. Whatever you chunk, accordingly you will retrieve the answer as the output. So make sure the chunks contain semantic meaning in order for the model to predict accurate results, right? So now you know the LLM results depend on the way we chunk the input data, right? So with this, I hope you understood what chunking is and what are the different text chunking methods and practical implementation too, right? So try implementing these different chunking methods when you are building any generative AI applications, right? Thank you.